So the next question we have is reachable node with restriction. So we are given a tree and we need to return the count of the nodes where we can reach. So there are some nodes which are restricted nodes. We cannot go ahead of that. So we are given an undirected tree and we need to return back how many nodes we can reach from 0. So can anyone tell like how do we solve this question?
I used BFS here. What I did
Okay.
was basically I created an adjacency list. Then first time I made this whatever is the restricted. Based on that, I made those nodes as visited as true for those numbers basically. And in the queue I inserted 0. And I did BFS and took the count of whatever was the output.
So basically you are doing a traversal on this tree and like you are saying like I'll stop when I find a node which is already visited, right?
Yes, yes.
Yeah, that could be one a good approach, right? So if I ask this question, like if we have only one node, so let me take. Let's say if we have only one node and that is not restricted. So what will be the answer? This node is 0.
Yeah, it will be 1 because 0 we are considering that by itself is a is also taken into account, right? So
Right. Now, if it is a restricted node, then
we can return as 1. No, you can return as 0 because 0 itself is restricted.
Yeah, if it is restricted, then we have to return 0. If it is not restricted, then we can return 1 because that node is, I mean, we can explore, right?
Yeah, right.
Okay, fine. So, so to solve this question, basically, like we can make 2 things. One is like metrics to hold this graph, sorry, tree, or a adjacency list, like as you said, like we can have a adjacency list which can hold like from the current node we can go to which all other nodes and then try to do a traversal. So we can do DFS or BFS both. I think it's just an traversal problem, right? So if we take the same node,
And
I'm trying to build an
kind of to think about the time complexity of depth first search or breadth first search is how much? Because what is the time complexity of depth first search or breadth first search in a graph? Come on, guys, this is okay. Yeah, thanks, Madhusudan. Yeah, it is V plus E. If we go down to the constraints, number of vertices plus number of edges. If we go down and see what is the number of vertices in the tree, if it is a tree, number of edges is guaranteed to be. If you have a tree of n vertices, what is the number of edges going to be? If it is guaranteed, it's a tree. In tree, you will not have cycles. So number of edges are always V minus 1 in any tree. I mean, it is n-ary tree. So constraints wise, Kaushik, what was the maximum vertices given here? Yeah, 10 power 5.
So, like, yeah, 10 power 5.
Yeah, Kaushik, go on.
Yeah, so in maths, like we can have 10 power 5 nodes. And because it's a tree, we'll have n minus 1 edges. So if we build adjacency list, then from 0 we can go to 1, 4, 5. Similarly, from 1, because it's undirected, we can go either way. From 2, we can go to 1. From 3, we can go to 1. From 4, we can go to 0. From 5, we can go to 0 or 6. And from 6, we can go to 5. So here, like, this is a adjacency list. But one more thing, like, one more information is given that there are few nodes which are restricted node. So what would be a good data structure where we can hold this restricted node, so that while we are traversing, we can easily search it, like whether this node is restricted node or not. So yeah, set is one way. Yeah, map set, anything, or unordered set, these things can be used. Or if we are maintaining a visited array, then basically we can keep this 4, 5 before ahead, like 4, 5 are already visited. So let's take a visited. I'll just sort this. So I'll take a visited set where I'll insert 4 and 5, because I don't want to, go ahead from this 4 and 5. So it's both the ways are possible. Like we can do DFS and BFS over here. But let's say if we do DFS, we start from 0. So from 0, we go to node 1. From node 1, what are the options? 0 and 2. So while going from 0 to 1, we mark 0 as visited. Right? From 1, we have two options, 0 and 2. So 0, because it's already visited, we don't go ahead from 1 to 0 again. So we explore another option, which is 2. So from 1, we'll go to 2. And from 2, while going to 2, we'll mark the current node as visited. So 1 will also become visited. Now, once we go to 2, from 2, we have only one choice, that is 1, and 1 is already visited. So here, basically, what we can do is, just let me draw the complete tree once. So I'm avoiding discussing the traversal. Basically, when we are at leaf node, the thing which we discussed, base condition, if we are at any leaf node and it is not a restricted node, basically the answer will be 1. So what this two can do is it can return 1 to its parent. And similarly, 3 is not a restricted node. So 3 can return 1 to its parents. Now, what 1 can do is whatever is returning from all its children's, it can add it and return 1 to its parents. So basically from left side, I'll get 1, right side, I'll get 1, and 1 will be added for itself, and it will return 3 to the top. So 0 will get 3 from 1, and that is the count from this subtree. Similarly, from 0, when we go to 5, because 5 is a restricted node, we return 0. That is what we discussed earlier. Like if there is only single node and it is restricted, then we can return 0 from there. So 5 will return 0, will not explore anything which is going ahead from 5. Similarly, 4 will return 0. So what 0 will do is it is getting 0 from 4, 0 from 5, and 3 from 1. So it will add all, that is 3 plus 1, 3 plus 0 plus 0 plus 1 for itself, and return that. So finally from here, 4 would be returned. So while this traversal, like whatever is the time complexity of DFS, that will be the time complexity for this as well. Did everyone get it?
One more thing just to add here. When we do depth first search on a tree, ideally we can avoid using visited array also. So Kaushik, if you don't mind, can you open a notepad? Or basically somewhere you can type the code?
Sure.
Yeah, I mean, this is just to talk one variation. That in tree doing DFS is much simpler than doing a DFS on a graph. And typically people avoid using visited array, although in this we will need. So it is just that if you write void DFS, DFS, in this DFS we will pass adjacency list. Yeah, you can just take adjacency, just write AL. Yeah, just write AL. I think people will understand. Adjacency list, comma, source S. This is start vertex, comma, parent. So if we pass parent also along with a source, then simple thing that becomes, we can avoid visited array. We can go inside the DFS. And what we do is, yeah, inside Kaushik, just write one loop for NS, neighbor of source, NS. Yeah, it's just a pseudocode, NS in AL of SRC, in AL of SRC. In adjacency list, we are looking at all the neighbors of our source. For every neighbor, we will just put a check here. If NS is not equal to parent, if NS is not equal to parent, we call DFS.
Yeah.
Yeah, and then we do a DFS call. With AL, guys, can you tell what will be the source now and what will be the parent now? Yeah,
NS will be the
source, and who will be the parent?
And SRC will be the parent.
Yes, SRC will become the parent. Yeah. So if we go and do DFS this way, we actually avoid using visited array. And a reason this works is because we know that from current node, which is the source node, if you go to diagram above, there is only one path that takes us back to the visited. Like if imagine if you are at, imagine if you are at 1, from 1, all other paths are valid or all other paths are not visited except the path back to 0. And this will hold true everywhere. So visited is something that becomes redundant to use if we are doing a DFS on a tree and we know it's a special graph. Tree is a special form of graph. Okay, so yeah, this was just a simple traversal problem. Any other questions, any other point from anybody, or we move to the next question? Okay, I think we are good for next.